Hello mathematicians. Today we are going to talk about dividing monomials. So if we have something with the same base, so x to the fifth and x cubed, they're both x's. I want us to think about what's going on here. X to the fifth means how many x's did we have? 5 x's being multiplied. X cubed means 3 x's being multiplied. Now, you know a number over itself is just 1, so that cancels as 1. X over x is just 1. X over x is just 1. This leaves how many x's on top? 2. So we would have x squared over anything on bottom? No. Looking at this 2, how could I get there with 5 and 3? Right. You're going to subtract them. The quotient of powers rule says if you have the same base, subtract your exponents. So 5 minus 3 is 2, and it stays on top because 5 is bigger than 3. Right. There were more x's on top, so the leftover will be on top. If the leftover was on bottom, you'd have it on bottom. But since there are more x's on top, the leftovers will be up there. So subtract those exponents if it is division. So if we use that rule, I'm going to first look at my x's. Do I have more x's on top or bottom? Top. So any leftover x's will be on top. If I have 3 on top, 2 on bottom, how many are left over after we cancel out? 1 exponent on top. X on top. What about my y's? Y to the fourth over y. Do I have more y's on top or bottom? On top. After I cancel or subtract my exponents, 4 minus 1 is 3. Y cubed will be on top because I had more exponents on top. Go ahead and try this next one on your own. Let's see how you did. For your a's, did you have more a's on top or bottom? On top. How many a's are left after you subtract? 2 minus 1 is 1. B to the fifth minus or over b to the fourth. So minus, and you had b to the first. And did anything down here cancel with c? No. Do you need to have the 1 exponent? No. So a, b, c squared. Since the larger number was on top, I'm going to leave my exponent piece on top. Nice job. The next one is power of a quotient. And that means each piece inside is going to get the exponent. So if it's a divided by b to the m power, each piece gets that exponent. So if I do that here, the x is going to get the exponent, and the y is going to get the exponent. So this will be x to the fourth all over y to the fourth. These are not the same base, so I cannot simplify or cancel any exponents. Nice job. For number 2, I have many pieces inside. So each piece inside is going to get the 3 exponent. So if I give that to each piece, I'm going to have 3 to the third, x fourth to the third, and all of that over 4 to the third. I'm going to have to do a little bit of simplifying here. 3 cubed means 3 times 3 times 3, which is 27. Yesterday we talked about an exponent to an exponent. Okay. What do you do with these exponents here? Multiply. This will become x to the 12th all over 4 cubed. 4 times 4 is 16. 16 times 4 64. If you can simplify those, okay. Otherwise, leave it be. Nice job. The next piece we need to look at is a zero exponent. Any number or letter to the 0 is 1, with the exception of 0. 0 to the 0 power is still 0. Okay? Anything to the 0, though, is just 1. So if I look at this, I have many pieces inside to the what power? 0. Anything to the 0 power is 1. Anything to the 0 power is just 1. Unless it is 0. That's it. Here, what piece is going to be 1? S to the 0 is just going to become 1. So this really leaves us t to the 4th all over t squared. And now this is what we did earlier. If I have 4 t's on top and 2 t's on bottom, how many t's do I have left? 2 t's, and will they be on top or bottom? On top. Subtract these, because you're going to have 2 of them cancel. And they'll be left over on top, because that's where we had the most. Nice job. The last one we have to talk about is negative exponents. A negative exponent means it must move. So if I have a to the negative n, I need to move it down into the denominator, and it will become positive. Also, if I have a to the negative n in the denominator, I need to move it to the top, and it will become a positive exponent. You cannot have negative exponents. They must be moved. Right? So this first example, 1 over m to the negative 5th. Can we have a negative 5 exponent? No. So what do I must do with it? Move it to the top. And it will become positive. M to the 5th. So 1 over m to the negative 5th, move that piece up. And it'll become positive. What about this one? What should you do? It's a negative exponent. Can we have negative exponents? No, so what do we do? Move it to the bottom into the denominator. 1 over x squared. Move that piece to the denominator. Try this next one on your own. Let's see how you did. Can we have a negative 2 exponent? No, so what did you do with it? Move it to the denominator, and that becomes 1 over 5 squared. The negative 2 becomes 2 when you move it. And what is 5 squared? 25. Simplify if you can. We're going to put all of that information together in this last example. First thing I want you to do is move any exponents that are negative. So that one must move. X to the negative 3rd must move. Y to the negative 2 and z to the negative 1 must move spots. So 24 will stay. X squared is now gone, but what comes up top? X cubed. So that piece is taken care of. Y to the 4th stays. It's positive. What else comes to the top? Y to the negative 2 becomes y squared. That's taken care of. And lastly, what else comes to the top? Z to the negative 1 becomes Z to the 1, or just Z. What do we have in bottom? The negative 6 still. Our numbers don't move. None of these are left over. They all move to the top because they were all negative. However, what moves it down to the bottom? X to the negative 2 becomes x squared. So move any negative piece, move it up or move it down, depending where it started at. Let's do some simplifying. 24 over negative 6, negative 4. X cubed over x squared. Where are there more x's? In top. How many are left over after they cancel? 3 minus 1. 3 minus 2, which is 1. I have two different y's here. We talked about this yesterday. If we have the same base, what do we do with these exponents? Add them. Y to the 6th. And anything happen with our z? No. So move any negative exponents, simplify, use our rules to combine and simplify. Nice job today, mathematicians.